Hello everyone, welcome back. COCC, this is Welding Technology 1. We are starting into Chapter 11, Shielded Metal Arc Welding Principles. It's kind of an oddly named chapter because what we're going to be talking a lot about welding machines, power sources, and so forth. Into the next chapter we'll get more into the electrode identification and so forth. But let's start out. Chapter 11 starts on page 286. You can follow along the PowerPoints. If not, feel free to follow on both. Okay, the first chapter, or the first paragraph in the chapter, page 286, left-hand column top. I'm going to read from it. There's going to be some questions possibly come out of this section. Shielded metal arc welding is manual arc welding in which the heat for welding is generated by an electric arc established between a flux-covered consumable metal rod called the electrode and the work. So the work is the piece that you're actually welding, okay? Let's continue reading. For this reason, the process is also called stick electrode welding. The combustion and decomposition of the electrode creates a gaseous shield that protects the electrode tip, weld puddle, arc, and the highly heated work from atmospheric contamination. Now that was a really important sentence right there. Let's read it again. The combustion and decomposition of the electrode creates a gaseous shield that protects the electrode tip, the weld puddle, arc, and the highly heated work from atmospheric contamination. Okay? Let's finish out the paragraph and then we'll talk about it for a minute. Additional shielding is provided for the molten metal in the weld pool by a covering of molten slag or flux. Doesn't have a brief overview. So, it says in there that it's often referred to as stick welding. Most people will call it stick welding. We want to start making sure that we use the correct terminology, okay? So from now on, it's shielded metal arc welding. A lot of times most people do refer to it as stick welding. It's an electrode with a slag outside exterior. You can see it on page figure 11-1 right here. So in this case, this is the core metal electrode, okay? And then this is the electrode coating or the flux on the outside. So the majority of our alloying and material actually comes from the flux. We can get iron powder, green powder, iron powder, granular flux to be able to add and help alloy the material that we're welding as well as just the filler metal. Okay. Move over to process capability, page 287, left-hand column on the top. Let's go through here, we'll catch up. Here's the objectives, okay? Heat for welding is generated by an electric arc established between the flux-covered consumable metal rod, the electrode, and the work. Okay, it's called stick electrode welding. Again, we want to refer to it as shielded metal arc welding. This is what it used to be called, but in order to make clear definitions on blueprints, process plans, and so forth, we use a lot of abbreviations in all the trades. Okay, so if you see a welding procedure and it says SMAW, okay, that means shielded metal arc welding. So we know in that case we're using an electrode. That's the welding process we'll be using. Say for example we just put SW for stick welding. Well, guess what SW is? It's actually stud welding. Different process. There's so many welding processes out there that we need to make sure that our abbreviations are very clear so that we can see and interpret those on a blueprint as well. Okay? One of the most important things to understand is it's this gaseous shield, and then it also, while we're welding, that gaseous shield created by the flux and the slag is what protects not just the tip, but the weld pool. It keeps moisture, sand, dirt, grease, and so forth from getting in it. The arc The more stable the arc, the easier it is to control, the better weld and control you're going to have as, while welding. Highly heated work from atmospheric contamination. Again, we don't have as much humidity here, but say we're over in Portland or on the coast or down south when we're welding, there's a high humidity factor there as well. So and we'll get into later on that we need to keep rods dry and so forth. But it's really important to think that that weld pull, it's heat. It's almost 9,000 degrees in the center sometimes. So that heat can pull that moisture into it. It's very important that if our flux is busted off or something like that, that we need to get a new electrode, start with a new clean electrode and so forth, reevaluate what we're doing, okay? Additional shielding is provided by the covering of slag flux. Alright, so here we are. Here's our base metal. In the book, it referred to it as the workpiece. So a lot of times our work is just the piece that we're welding, okay? And then our electrode. So you can tell this one, because notice how it's got a solidified slag on the top here of this weld profile, okay? Now here's actually the weldment, here's the solidified weld metal. But here's that little layer of stuff that we have to make sure that we don't go too fast. If we don't have any slag here whatsoever, then that means our travel speed is way too fast. We need to slow down, let this flux do what it's designed to do. Let it bring all the impurities out of this liquid metal and bring it to the surface so we can wipe them away. Okay, that's what it's designed to do. Don't be scared to go too slow at the beginning. Okay? A lot of times people starting out, natural habit, everybody's done it, including myself. You're gonna strike up and everything's happening so fast that you're really nervous about like slowing down. You start it and you're gonna want to kind of go. Okay, because it's kind of like riding a bike. Everything's all new at once. Okay, the more repetition, the more and more we do this, it's going to slow down to where it's no big deal. All of a sudden, you're going to be able to strike it, help feed, create a long arc, short arc, manipulate the electrode any way you want, move forward, and get a nice even weld bead coming along as we're doing this. Okay. All right. Process capability. Shielded metal arc welding, one of the most used of various electric arc welding processes. So, let's look at it here. Here's shielded metal arc welding, 42%. The next one is the GMA or flux core. Gas metal arc welding, most commonly known as MIG, or a flux core type. Now these two, they all have their advantages and disadvantages. These are going to be a lot faster. Higher production, but they're limited to no wind, very limited atmospheric interruption, so forth. Shielded metal arc welding, you know, I've had it blowing 50, 60 mile an hour winds and still been able to weld with shielded metal arc welding. So you go outside and it's a windy day, usually you can't create a good quality weld using GMAW or flux core, but using shielded metal arc welding, we can. Okay? That's what makes it so widely used across the country and the world, as a matter of fact. Okay, let's read from the book. Page 287, left-hand column, under process capability. Shielded metal arc welding is one of the most widely used of the various electric arc welding processes. Drop down a paragraph, it starts out, according to a recent market study of equipment and process usage among the industrial market segments, SMAW represents 42%, GMA flux core 34%, gas tungsten arc welding 13%, also formerly known as TIG, tungsten inert gas. Now we call it gas tungsten arc welding. SAW, which is submerged arc welding, 9%, and others 2% of the total welding. However, when looking at the dominant markets using SMAW, 56% of construction welding is SMAW and 61% of maintenance and repair is SMAW. Now that's a pretty important part, okay? Right there. 56% of construction and 61% of maintenance and repair. One of the reasons why, let's get into why. Okay, jump down, next paragraph, we'll start in it. Equipment for shielded metal arc welding is less complex, more portable, and less costly than that for other arc welding processes. This type of welding can be done indoors and outdoors in any location and in any position. Shielded metal, next paragraph, shielded metal arc electrodes are available to match the properties and strength of most base metals. Metals most easily welded by the shielded metal arc process are carbon and low alloy steels, stainless steels, and heat resisting steels. And this still holds very true today. Say we're doing an odd brand of alloyed material. Say we're doing a high strength low alloy steel, okay? So we need to have a certain amount of nickel in it, maybe some molybdenum, some chrome, so forth. It's hard to find many welding supply houses that will stock the odd varieties of wire, okay? Plus, you might need a special gas, like a trimix gas to run a stainless weld. So that's pretty hard to find sometimes too. Or you can usually commonly go down and find, most welding supply houses will stock a 316 electrode for you, okay? Or a 309 for dissimilar metals and so forth. Stainless steel electrode, 11018, C-2. We'll get into that in the next chapter, but I just kind of want to give you an overview of how it's a lot less expensive equipment and it's a lot less complex as well. You don't have to have as many parts, you just got to have a machine to weld and the right stick instead of gases and the correct wires, and they're harder to find as well, okay? So, as we're moving on through this chapter, we'll discuss a little bit more of that, and into the next chapter, we'll break down electrode identification, so you'll start understanding what all of those numbers mean as we're going through them, okay? All right. This is also one of the most important things that you really need to understand, is you have to match the properties and strength of the base metal, okay? So for example, if I'm welding stainless steel material, I cannot weld it with a carbon electrode, a normal alloyed carbon electrode, so 7018 normal steel, okay? I would have to weld it with stainless, because we cannot weld carbon on stainless material. However, we can go vice versa. We can use a stainless welding rod or filler metal in order to, electrode or filler metal, to weld on carbon normal steel. It's just kind of one of the laws of physics of what materials are compatible, which materials are compatible with which electrodes. So out of many things that you'll do, this is quite possibly one of the most important pieces of all welding right here, is that you make sure to use whichever electrode, wire, or filler metal you're using, even if it's gas tungsten arc welding. If you're welding A36 steel, you want to make sure you're using a ER70S-2 or 6, so forth, so that the base metal is compatible and it mechanically will bond together, okay? All right, if you want to go back to the book, let's look at operating principles, page 287, right-hand column, top paragraph. Shielded metal arc welding equipment sets up an electric circuit that includes the welding machine, the work, electrode cables, the electrode holder and electrodes, and a work clamp. The heat of the electric arc brings the work to be welded and the consumable electrode to a molten state. The heat of the arc is intense. Temperatures as high as 9,000 degrees Fahrenheit, 5,000 degrees Celsius have been measured at its center of the arc. That's pretty hot, pretty bright, okay? Something to keep in mind as well, you know, we have an electrode here that's a base core wire, a filler metal. A lot of times it's just a rim steel, okay? And then we're putting alloying in by this flux, whether it be a sodium cellulose type, 6010, or if it's a 7018, which is an iron powder, low hydrogen type, your flux may vary as far as thickness and quantity, okay? Sorry, I lost where I was at there for a second. Oh, okay. So, one thing to keep in mind is how do we get that to blend and disperse evenly? Well, the easiest way to process anything is to do it in a liquid format, because when it's in a liquid state, then the molecules can disperse evenly at a normal, or an even rate, I should say. Not a normal, but at an even rate or pattern. And then they'll solidify on their own when they find their home position. We'll talk more about the metallurgical standards going through the program as well later on. But I wanted to just discuss, this is when most of the alloying takes place. It's not right here, or it's not on the slag. That flux is absorbed into that weld puddle at 9,000 degrees, and it spreads out evenly and disperses, and then all of a sudden it solidifies together, and then that's when the slag brings all the impurities, or kind of the garbage, so to say, to the top, the things that the weld pool rejects, okay, that doesn't bond to the metal. That's how they'll bring this here. Now originally, during forge welding and so forth, back in the day they used to use things like glass and sand. It would be used as a flux to help draw those impurities and discontinuities to the surface, okay? All right. Moving on to welding processes. So at this point in the course, you've probably already been out there welding some. You're probably very familiar with how it works. You have your electrode, you have your workpiece, and you're going to strike it just like a wooden match. Now, as you get better and more experienced, you can bring it down in nice and easy and just tap it. But when you're first starting out, the best thing is just kind of like a wooden match. Just strike it this way and come back to it, okay? And then let it kind of, the arc stabilize and the pool get big, and then you start dragging along or oscillating it in any manner that you would like to, okay? Okay, I'm going to go to the book, page 288, chapter 11. Left-hand column, 1, 2, third paragraph down, it starts out the arc welding processes. Okay? So here's a good example. You got your weld machine, your power source. Here's your cable. This would be your ground. Okay? Here's your other welding cable. This is your electrode holder, electrode. And we've got cool sparks until they start dropping down your neck and everywhere else. So again, it's important to wear the proper protective equipment, personal protective equipment, okay? Okay, back to the page. We're under welding power sources, page 288, left-hand column, third paragraph down. It starts out, the arc welding process requires enough electric current, which is measured in amperes, to produce melting of the work and the metal electrode and the power voltage, measured in volts, to maintain the arc. Depending on their size and type, electrodes require 17 to 45 volts and approximately 100 to 500 amps. The current can be alternating or direct, but it must be provided through a source that can be controlled to meet the many conditions encountered on the job. This is the most, it's a big piece right here. It must meet the changing arc load and environmental conditions instantly, okay? So if you don't have, say you have a machine that will only weld up to 85 amps and you're running 7018 electrodes, 1/8 inch diameter, you're going to need to maintain at least 105 to 135. You don't have enough machine to be able to correctly weld. I'm not saying it can't be done. The weld will be able to be started, but it'll be a very poor weld, not a pure weld, a lot of issues within it, so forth. So make sure you have the correct machine, or the correct electrode. Now, say we take that machine that can only weld to 85, 90 amps, and we wanted to weld to 7018. Does that mean we can't weld anything? Absolutely not. Say we drop down, our electrode diameter drops down to a 332 instead of 1/8 of an inch. On 332, we're going to run approximately 80 to 90 amps. Okay? So, now we've got a weld machine. We can create a good quality weld, a solid weld, with the correct electrode designation, filler metal designation, along with the welding machine powerful enough or producing enough electricity to do so. Just a general rule of thumb real quick. We'll start talking about math and the trades, so forth. It's very important. Here's a little tidbit to kind of help you, put you on the right ballpark for amps dealing with 7018 electrodes specifically, okay? So 1/8 inch, if we look at it as a decimal point in thousandths, it's 0.125, right? Because 1 inch is 1,000, half is 0.500, quarter is 0.250, and then we take half a quarter, we're down to 1/8, so we take that 0.250, cut it in half to a 0.125, okay? So what did I say we needed amp-wise to be able to run 7018 electrode? We needed 125 amps as a general starting rule. We can go down to 105 to 135, but just something to kind of keep in mind. It's a good starting point for a lot of electrodes out there. Now, if you try to do 6010, 1/8 inch with 125, you are going to be burning really, really hot, and your weld pool and your electric arc is going to be very volatile, okay? It's a little bit different. So that rule kind of only applies to 7018. In most low hydrogen electrodes, so 7015, 16, 18, they'll usually get you in the right ballpark, okay? All right. Okay, page 288, chapter 11, drop down 2 paragraphs. It starts out, welding power sources are also known as power supplies and welding machines. All machines may be classified by either an output slope, which is constant current or constant voltage, or number 2, a power source type, such as transformer, transformer rectifier, inverter, or generator. They're basically, they can be both. Okay, so when I said or, they're more than likely going to be both of these. They're either constant current or constant voltage. Okay, and then how do we get to that? The power source is either transformer, transformer rectifier, inverter, or an engine-driven generator. Okay, these two right here are very important. So constant current is, we're going to run constant current, so you're maintaining the current, which is the amps. Okay, it's staying solid. The amps, say we set it at 90, it's trying to maintain that 90-degree window. Does it fluctuate up and down some? Yes, absolutely. It'll fluctuate off of your distance to workpiece and so forth. There's a lot of factors in there that make a big change. Okay. However, it's trying to maintain the current or the amps. So this is mainly used in shielded metal arc welding, gas tungsten arc welding, so forth. Now, constant voltage, we're trying to maintain the voltage, and the amps is what fluctuates depending on distance from workpiece, travel speed. There's so many variables in welding that you're going to start figuring out. You change the variable, something else can be affected. Okay? Constant voltage, flux core arc welding, gas metal arc welding, primary uses for it. Okay? Is there always a rare case to where you can find a different type? Yes, there's always a rare case. 99% of the time, constant current, you're going to be shielded metal arc welding, gas tungsten arc welding. Constant voltage, you're going to be